In this video, we will understand about cyber physical systems, which are one of the important pillars for Industry 4. A cyber physical system consists of cyber components and physical components, so we call it as a cyber physical system. And in short, we call it a CPS, which is based on an information processing computer system, which is embedded into a product, car, plane, or any other device. In this presentation, we will try to understand about what is cybersecurity, and what are cyber physical system, and what is its role in Industry 4, and how do we build a system, and what kind of architecture does it look like. And if you really see, Industry 4 is built on key technologies, which are cyber physical systems and Internet of Things. And then we build the manufacturing processes services over it, and we use our cloud services or the internet services to automate our systems and make it industry ready for our latest technologies. What is the cybersecurity? Cybersecurity is the practice of defending computers, servers, mobile devices, electronic systems, networks, and data from malicious attacks. It's also known as information technology security or electronic information. Cybersecurity is also called the state or process of predicting or recovering networks, devices, programs from any other type of cyber attack. A strong cybersecurity system has multiple layers of protection spread across computers, devices, networks, and programs. And as we have seen, any latest smart factory would have a lot of devices, sensors, and interconnected devices, and that's why we need systems and software to keep them secure, keep them working throughout the duration of manufacturing processes. What is a cyber physical system? As we have seen, cyber means any IT-related product, service, software, and physical means the physical component which gets moved because of the software, which is the processing which is happening. So cyber components are the computation network for CPS. They have a processing unit. They have human management interfaces where humans are interacting with them and controlling the devices. In the physical component, we have the actuator, the sensor, the embedded system, and the computer system through which the physical systems operate. So when we look at the cyber physical system Industry 4, what kind of cyber and physical systems are we looking at? Sensors and the actuators are the physical systems, while computing and communications and storage are the cyber part. In storage, we try to maintain the data and store it there. In the computing, we try to ensure that the information leakage is not happening, there is no timing error, the computing is working properly. And in communication, when the data is getting transmitted from sensors to the cloud computing and the devices, we have to see that there's no eavesdropping, packet modification, man-in-the-middle attack. These are all cyber attacks which we have been used to seeing in the cyber space here. In the actuators, when we look at it, there should not be any failure when the command is given to it. And the sensor should be proof of some attack so that nobody can misuse our machinery for causing damage to the manufacturing process or human part of it. So we need to build a secure system of all this computing and the physical parts of an Industry 4 here. So how do we define cyber physical systems? Cyber physical system consists of cyber component and physical component. So we call it cyber physical, as we have seen. Difference between Internet of Things and cyber physical systems is that IoTs are the objects and machines connected to the internet and eventually to each other, while cyber physical systems are integration of computational networking and physical processes. We will have a look at a video which tries to explain the cyber physical systems along with the components.
What does the term cyber physical systems actually mean? In this video I will show you the design, the main functions and the basic components of cyber physical systems. Cyber physical systems consists of physical components and cyber components. That's why we call them cyber physical. Actually, all cyberphysical systems are based on an information processing computer system, which is embedded into a product, like in a car, plane, or other devices. These computer systems are used to handle a specific task. So for example, in a car, an embedded system would be the ABS system to control the brake force. How does this work? These computer systems interact with the physical environment via sensors and via actuators. As a whole, this is called an embedded system. In a cyberphysical system, these embedded systems do not stand alone anymore. They share their data via a communication network like the internet with cloud computing. In that way, data from many embedded systems can be collected and processed. We can create a system of systems. Connected embedded systems can be controlled decentralized via one computational unit. Here, data can be processed automatically or by human-computer interface.
In the next presentation, we'll also we'll understand through this video the meaning, the definition, and the explanation of our cyber physical systems. So it brings a good clarity of this term.
A cyber-physical system, CPS, is a mechanism controlled or monitored by computer-based algorithms, tightly integrated with Internet and its users. In cyber-physical systems, physical and software components are deeply intertwined, each operating on different spatial and temporal scales, exhibiting multiple and distinct behavioral modalities, and interacting with each other in a myriad of ways that change with context. Examples of CPS include smart grid, autonomous automobile systems, medical monitoring, process control systems, robotic systems, and automatic pilot avionics. CPS involves transdisciplinary approaches, merging theory of cybernetics, mechatronics, design and process science. The process control is often referred to as embedded systems. In embedded systems, the emphasis tends to be more on the computational elements, and less on an intense link between the computational and physical elements. CPS is also similar to the Internet of Things, IIot, sharing the same basic architecture. Nevertheless, CPS presents a higher combination and coordination between physical and computational elements. Precursors of cyber-physical systems can be found in areas as diverse as aerospace, automotive, chemical processes, civil infrastructure, energy, healthcare, manufacturing, transportation, entertainment, and consumer appliances. Unlike more traditional embedded systems, a full-fledged CPS is typically designed as a network of interacting elements with physical input and output instead of as standalone devices. The notion is closely tied to concepts of robotics and sensor networks, with intelligence mechanisms proper of computational intelligence leading the pathway. Ongoing advances in science and engineering will improve the link between computational and physical elements by means of intelligent mechanisms, dramatically increasing the adaptability, autonomy, efficiency, functionality, reliability, safety, and usability of cyber-physical systems. This will broaden the potential of cyber-physical systems in several dimensions, including intervention, for example, collision avoidance; precision, for example, robotic surgery and nano-level manufacturing; operation in dangerous or inaccessible environments, for example, search and rescue, firefighting, and deep-sea exploration; coordination, for example, air traffic control, war fighting; efficiency, for example, zero-net energy buildings; and augmentation of human capabilities, for example, healthcare monitoring and delivery.
Another video will try to explain how the cyber physical system works in the production environment.
A self-organizing factory that entirely configures and organizes itself and responds to changing requirements, and where humans and machines seamlessly collaborate. This vision is becoming reality in the Siemens Living Lab for CyberPhysical Production Systems.
Alexa, trigger product logo echo.
Checking if we can produce it.
The manufacturing of a product starts in virtual reality with the help of simulation technologies. The CyberPhysical Production System first checks whether the production is feasible. The machines in the factory provide detailed information about their production skills and constraints. Based on this information, the system generates a digital twin of the product and compares the required production steps with the production skills of all machines and humans in the factory. The machine gets the knowledge of how the product shall be made directly from the digital twin. Based on the information about how the parts are to be assembled, the system dynamically calculates all necessary steps and carries out the production autonomously. This means that the product steers its own production. This is an important feature of Industry 4.0 solutions. Siemens enhances the skills of the machines through machine learning, intelligent sensors, and speech recognition. This optimizes the production process and increases the quality of the product. Safety requirements are also developed to ensure that people and machines can work together safely. In the future, cyber-physical production systems will better meet customer needs and manufacture products in a faster, more individualized, and more efficient manner.
Siemens. Ingenuity for life.
So what are the applications of CPS in the industry? In the future, as you have seen through this video, CPS will be present in all industrial sectors and within the Industry 4 paradigm. CPS will open a new production methodologies, becoming the standard of tomorrow for industry. Production environments will be self-configuring, self-adjusting, and self-optimizing, leading to a greater agility, flexibility, and cost-effectiveness. Every functional aspect of production chain will be affected, from design to manufacturing, through supply chains, and extending to customer service and support. And this can be seen through our illustration here, how the factory would be working in a manufacturing plant. There's a global facility, there's a customer side and global operations here. So they will be self-optimizing, they will be self-working here, when the humans will be just watching and intervening at the right moments here. So as we see through this video and this the animation videos and through these slides, we have seen the cyber physical systems are the important technological component, just like the IoT in the Industry 4, and they work on the systems level. They connect the devices in a secure manner and see that the whole production is carried out as per the latest smart technologies here. Thank you all for watching this video.